Okay, so distribution is nothing but the arrangement of all these values, all these probabilities in the form of a plot. Okay, distribution is nothing but the spread of the values. Okay, variance is the spread of the values actually, but distribution is representation of that in the form of a plot. Now for the above example, because we rolled the dice 5 times, okay, and we had 7,776 possible values, okay, outcomes, and to that what we started doing is, how many times will I get the sum as 5, how many times will I get the sum as 6, how many times will I get the sum as 7. So these probabilities we have calculated, and as you can see, the lesser the sum, lower is the probability, higher the sum, higher is the probability, and this keeps happening until it reaches certain point. Okay, and after it reaches the point of let's just say 15, 16, 17, 18, let's just say this bar is 18. After it reaches the point of 18, it starts to decrease. That means you getting a sum, very small sum, when you roll the dice 5 times is lower along with the higher values, higher sum and lower sum is less, something like poor class. So if you notice, poor class, the income earned by poor class will be less, income earned by higher class is high, the income earned by middle class is somewhere between, something like that. Okay, so same behavior is exhibited in rolling of dice. Now this is called as distribution. Distribution is nothing but a representation of probabilities in the form of a plot. Okay, and there are two different types of distributions, mainly on a brief level: discrete distributions and continuous distributions, that we will look at now. Okay, and for the same plot that we have plotted, for the sums we have plotted, right, notice how you are getting these bars. If you get these bars, then you have to understand this is a discrete variable. Okay, that we will talk about now. Okay, just showing you the possible probabilities. And if you also want to calculate what is the likelihood that I can get the sum between 14 and 21, then these are the probabilities. Okay, notice how the probability of you getting the sum is equivalent to 14, that is depicted in the graph also. If you notice, this 21, this is same as 14 here. Okay, yeah, so is this clear how to understand the
Yes.
probability distribution diagram? Yeah. Okay, fine. So now we will move on to the next topic. Okay, here we have to talk about various we have to talk about what is a random variable, what are the types of distributions it will represent, what is a continuous variable, what are the types of distributions it will represent, all of that we have to talk about. Okay, now a random variable is nothing but a variable that can take any number of finite values. Okay, a random variable is nothing but a variable that can take on many values. Okay, it can take any value basically, that is called as a random variable. Suppose you roll a dice twice. Okay, here x could be the, here in this example what they are talking about, x is a random variable, and you can simply assign the value as sum of 1 and 1 or sum of 6 and 6, both it can take. Okay, so that hence x is a random variable, it can accept any value. It is also known as stochastic variable. Okay, so don't worry about stochastic for now, we will get to that later. Now this random variable exhibits a random event and hence it generates a probability. Okay, so for example, you take a coin, you toss it. Okay, you keep tossing it, you will keep getting a variable. Randomly it will accept the value and randomly it will generate the probability, and end result will also be a probability. Now random variables are of two types mainly, okay, discrete variables and continuous variables. Very easy to understand. Discrete variables are nothing but non-decimal variables, non-decimal values. For example, you toss a coin, you have head, you have tails. Okay, head can be represented as 1, tails can be represented as 0. So that is a discrete value. It's a definite value. It doesn't have 1.123 4, 5, something like that. Continuous, on the other hand, is nothing but, continuous variable is nothing but, it has decimal points. Okay, all the probabilities are continuous random variables. Okay, continuous values, basically, not variable, values. But if those values are taken by random variable, then it becomes a continuous random variable. So essentially, even if you don't understand this concept that well, what you have to remember is, if you get these sort of bars like what we got here, these are all bars, right? So all these bars, if you get these sort of bars, you have to understand that you're talking about discrete random variable. Discrete random variables generate usually the frequency or the count bar or the bars in a distribution, whereas continuous variables, they don't have bars, they don't have any segregation, they rather have a smooth curve. Okay, so smooth distribution. So that you have to remember, that is the most important point here. Now discrete random variables, if you want to calculate the probability under the curve of this discrete random variable, we call it probability mass function. That means, for this bar, if I want to calculate how much area these bars, all these bars are occupying, we call it probability mass function. Whereas for continuous random variable, the same thing, we call it as probability density function. Mass function, density function. This is called as mass function, probability mass function, PMF. This is called as probability density function, PDF. Okay. Now discrete variable, there is a definition. So basically a variable that can take on finite number of distinct values, separate values. I will give you example. Example, if you are doing data analysis, you get a column where it talks about occupation. Okay, occupation could be it could be doctor, software engineer, he could be attendant, a receptionist, teacher, pilot, etc., etc. So all those values are nothing but they are definite values. Okay, those are all called as discrete variables. Okay, discrete random variables. Okay, and I will give you example for continuous also. Okay, so for continuous, if you calculate the number of the chances, basically chances of people winning the lottery. Okay, so there would be certain probability from this area, from again that way. Or another example I'll give you, the total see, random variable can be a population of a state. Okay, population of a state could be you can't have a half person, no, you can have only one person. So population, let's just say, of Karnataka is around 36 lakhs or 40 lakhs, whatever it is. Sorry, not 36 lakhs, my bad. 3.6 crore or 4.5 crore, whatever it is, the number is. So for that number you can't have a decimal value, because you can't have half human, you can have only full human. Okay, but on the other hand, income of Karnataka, that can end in decimal values, right? It could be certain so and so, some 1,000 or 6,500 crores, 35 lakhs or 40,210 point. It can go point certain paise or whatever it is. It can be a float value. So that will become a continuous random variable. Continuous random variable can be the income of all the states. Discrete random variable can be the population of the entire states, all the states. Okay, is that clear? Did you understand that?
Yes.
Okay.
So you mean
And
continuous variable is always increasing in the size or something like that?
yeah, increasing or decreasing doesn't matter. Okay, but it has to have a float value. Okay, that means it could be it could be the income could be like, for example, income of a person could be for this year could be one thing, next year it could be 10 lakhs 35,000 42 420 dot 42 1635 something like that. It could be a continuous value. Okay,
Okay.
and the discrete random variables exhibit four particular distributions. If you start arranging this discrete, the probabilities generated by these discrete random variables, if you start arranging in the form of a plot like what we have done here, it could exhibit four different characters. Okay, hence we define four different types of um, okay, hence it exhibits four different types of distributions. One is called as binomial distribution, geometric distribution, Bernoulli distribution, and Poisson distribution. Four different distributions. Okay. Now, binomial distribution is binomial. Bi means two. Okay, two results are obtained here. For example, tossing of a coin. There are only two outcomes, either success or failure. For example, transaction, either it could be a non-fraudulent transaction or it could be a fraudulent transaction. Results of an exam, either they can pass or they can fail, or a student can fail. Okay, only two options. Okay, such random variables are called as binomial random variables, and the probability is called as binomial, the distribution is called as binomial distribution, and it is represented by certain complex formula. Don't worry about the formula, nobody is going to ask you the formula and calculation, but what you have to understand is, by looking at the graph you should be able to understand what a binomial random variable looks like. Okay, now in geometric random variable, okay, it represents number of times you see the failure before success. Okay, how many times, consecutive times you have failure before success. Let's just say a cricket team introduced a new player, how many times he will fail to score 50 half century before he scores half century. Okay, so that probability or that distribution or that random variable is called as geometric random variable, and distribution is called as geometric distribution. Here the probability mass function is nothing but total area or the total sum of all the probabilities, okay, obtained, is given by this formula. If you pay attention, there is slight difference between this calculation. Don't worry about this formula and all, but just understand what are the different types. Now, a Bernoulli random variable is the simplest type. Here also it can take two possible values, one to represent a success and zero to represent a failure. Okay, it is very similar to binomial distribution. Okay, but the probability is very simple. Probability mass function is very simplistic. For example, if you get 1, you can get the calculate, you can directly calculate the probability with p, and if you get a 0 you can subtract the probability from is straightforward. For example, certain events are straightforward, right? If you toss a coin, the probability of you getting a head is 50%. Okay, and if you subtract, the probability of getting tails is again 50%, because 1 minus 50% is 50%. Here 1 represents heads, 0 represents tails. Okay, straightforward one. Bernoulli random distribution. But if you see Bernoulli versus binomial, there is a slight difference. Okay, Bernoulli, actually you can say Bernoulli is a special case of binomial distribution. 1 second, let me pull the differences. I will show you like this. Um, Okay, so in Bernoulli, okay, both are discrete probability distribution, but here you are going to calculate number of successes in a fixed number of independent trials. Okay, fixed number of independent trials. Here the number of trials are not fixed, that is the difference. Okay, so if you toss a coin only once, then it becomes a binomial distribution. But if you toss a coins, okay, here number of trials is 1, sorry, here number of trials is 1. Okay, so then it becomes Bernoulli. Binomial becomes if you toss it multiple times. So let's just say 100 times. If you toss a coin, then you can calculate the probability, so that will give you binomial distribution. And just like what we have done here, binomial, so we have calculated, we have rolled the dice how many times, 5 times, and for each time we have calculated the sum, how much sum you obtain. So this becomes a binomial distribution. Okay, and Bernoulli on the other hand is you will calculate the distribution only once. For example, you wrote an exam, okay, only once, that will be Bernoulli distribution. Here it is a single probability, but here it is the same probability for each trial. That means if you keep on tossing coins 100 times, each time the probability of you getting heads will be 50% only, because the next result is not dependent on the previous result. Okay, so that is the difference. Here probability can be represented in the form of either 0 or sorry, the occurrence of event can be represented in the form of 0 or 1, but here the occurrence of the sample space, that becomes like 0 to n. Okay, so we notice the coin, right? So one time you tossed initially when you tossed the coin once, it was Bernoulli, it was a Bernoulli distribution. Okay, but when you tossed it twice, you noticed how the sample space or the outcome space increased. So this became binomial. This is binomial, this is Bernoulli. Okay, that is what the difference is. Here variance is given by p into 1 minus p. Here you have to multiply n times in order to get it. Okay, so probability mass function is also given by the formula. Again, I will get back to this cumulative distributive function. But probability mass function differs with the formula. Okay, that is the difference. Okay, coming back to the random variables. So you have Bernoulli and binomial. Okay, this is for once and binomial is for multiple times. Next is we have Poisson. Poisson distribution is nothing but it will show you how many times an event will occur within a given time period. Now here there is an involvement of time. Okay, previously there was no time. Okay, for binomial also there is no time, and for geometric also there is no time, but for Poisson distribution there is a time factor. So how many times you will get an event occurrence within given time. For example, if it just before starting to rain, how many times will I get the lightning within certain given time period is what we want to calculate. That random variable is called as Poisson random variable, and the distribution that you obtained is Poisson distribution. We will see each one of them one by one. Okay, and this is about random variables. Now we will start looking at each one of them one by one. So I have mentioned the same formula, same explanation, everything that we just saw. For binomial distribution, what you have to check few things. Okay, you have to check, first thing you will check is, are the events, are the number of repetitions you are doing, are they independent, okay, or non-independent? That is one. They have to be independent. That is first thing. Second thing is, are they being repeated or not repeated? To understand if a distribution is binomial or not, these are the things you have to check. And what are the end results? Either you are getting success or failures, or you are getting success, failures, and draw. Another option is also there. So that way, if you are getting draw, it no longer is binomial distribution. You have to have only two outcomes, and it has two outcomes should repeat multiple times, and it should be independent. Okay, that is how you identify the binomial distribution. And here you will notice two different parameters. N is number of times the event is being repeated, and each time how much probability you are getting. Okay, for us, we don't worry about all this theory. Okay, we straightforward go to the functions. So we have a SciPy library. From there we import the statistics, and for statistics you can apply the binomial directly, and you can also calculate the probability mass function of 3, 7, 1 by 6. I will explain what these are. Let's just say you roll a dice 7 times. So total number of times you rolled is 7. So hence you have taken 7, and you're calculating what are the chances that in out of those 7 rolls I'll get 3 times I'll get 6, or 3 times I'll get 1, or 3 times I'll get 2, 3 times I'll get 4, whatever it is. So how many times you'll get, how many times repeatedly you're calculating, so that you have to take here 3, 7, and for each time what is, if you roll the it once, what is the probability? It is 1 by 6, so that you have to provide it here. So basically you have to provide, if I do this, you have to provide 3 different values, k and argument, and they have mentioned keyword arguments, don't worry about it, but you have to provide p, k, n, p. K means the number of times you're going to repeat, that is k value. N value is total number of times you're going to roll. P value is what is the probability for single case. When you calculate this, you will immediately get the answer. Okay, so the probability is, okay, roughly 8%. Okay, this is also mentioned here, roughly 8% you will get it. 3 times you can get 6. If you roll the dice 7 times, roughly 8%. Okay, so same way you can also calculate, but let's just say you don't want to calculate 3 times, but you want to calculate how many times you can get 6, how many times, what is the probability of you getting 6 twice, what is the probability of you getting 6 3 times, what is the probability of you getting 6 4 times. So that also you can calculate directly by passing a list here. If you pass a list, you will get, okay. So the probability of you getting a 6 between 2 and 4 times is sum of all this. Okay, if you sum it, if you add the sum function to all of that, you will get 32.8% or 33% of the time. Okay, 1 by 3 times you will get 2, 3 or 4. Repeatedly you will get any number, any particular number. Here we are talking about 6 number, it could be 1, 2, 3, whatever it is. Okay, is this clear up until this point?
Yes.
Okay, up until this point, if it is clear, I would like to stop it here because it's 9:30. I want you to have finished breakfast and come back at 10, please. Okay.
Okay. 10 o'clock.
Yeah.